Hi, my name is Eric Anderson. I'm going to show you how easy it is to do IP rate analysis with the SynMax Python add-in. So first thing we need to do is install the add-in. That's pip install -- upgrade to make sure we have the latest version, SynMax API Python client. Then up here, I'm also going to install some other packages we're going to use today. We're going to use Plotly for graphing, GeoPandas for storing data that is geographical in nature, and PyShape to do plotting of different counties. After you've imported all of the data by using from.synmax.hyperion, import, and then the four items we want to grab are the Hyperion API client, which allows us to communicate with the server very performantly, the API payload, which allows us to do filtering, and then add daily and get FIPS. I'll go into these in more detail later, but basically add daily lets you very quickly convert monthly production numbers into daily production numbers, and get FIPS lets you very quickly map counties onto FIPS codes, which is used with a lot of mapping software. So the first thing we need to do is get the production data. To do that, we're going to call a Hyperion API client object and create an instance of it called client, and we're going to put our access token in there. If you don't have your access token anymore, you can contact me, eric@synmax.com. I'll resend it to you. After you create the client object, you are going to create a filter using the API payload class. And to that, I'm going to pass some filters. For this example, I want to get all the production data in Texas for the last 18 months, and I want to look at just production month number 2, because I'm going to do IP rate analysis. With a fract well, typically the highest point of production is actually in month 2, because month 1 is always partial, and as flowback occurs, there's usually a trade-off between the amount of water being pulled out of the well and the amount of hydrocarbons coming out of the well, which means that month 2 is the best bet for trying to do IP rate analysis. So that's why I'm picking production month 2. I'm going to pass that into the client object where I'm querying production by well and spit that out into a data frame. So let's run that. You can see our server is very fast. We get results back in about a second, and we have a lot of data here. So in total, we've got 7,600 rows. We have the unique identifier of the well, the API. We've got the county it's located in. We've got the production date, and then we've got the important fields: gas monthly and oil monthly. This is information that comes from the state, and they always report it monthly data, right? We want to be able to see this in daily terms, because if we're going to do IP rate analysis, we have to control for the fact that different months have different number of days, right? February would almost always be smaller than January if we didn't control for it. So the very next thing I'm going to do is I'm going to use this add daily, which comes from the SynMax package, to just seamlessly add those daily columns into the data frame. So let me run that real quick. And it spits out, you see I still have my monthly columns, gas monthly and oil monthly, but if I scroll over all the way to the right, I now have daily columns too, where this has done the work to calculate what the daily rate of gas in those months mean. All right, so now that I've got daily gas data in a data frame, it's really easy for me to use Plotly to graph some different histograms of it. So here I've got Martin, and I'm looking at oil data. Okay, so this is barrels per day for all of the wells in the last 18 months in Martin County. You can see it's tapping out. The median looks like it's around 900, 850 or 900 or so. Let's do the same thing, but let's look at Midland. Okay, very different profile, tapping out maybe a little bit higher, around 1,000 or so, and a much wider range. Let's look at what Midland is like for gas. So in gas, this is MCF per day, a little bit more narrow, also coming in around 1,000. Let's see what it looks like for Culberson. Culberson for gas. Wow, Culberson obviously has much higher IP rates than Reeves. It's interesting because both those counties are both inside the Permian play, but the further west you go in the Permian, the drier and gassier it tends to be. And so in order for us to look at that really in detail, we're going to need a map. So the first thing we do if we want to create a map is we got to take all of the individual counties and we got to calculate the average IP rate for gas and for oil. And to do that, we're going to use a group by function. So what does group by do? Well, you take a set of unique columns that you want to keep unique, and then you calculate a statistic on all the columns that are not those unique columns. So in this case, my unique columns will be a combination of the state column and the county column, and then the statistic I want to calculate on is for oil daily and gas daily, and I want to use the mean, right? So if I run that, let's see what it looks like. So I get a much smaller data frame here, just 174 rows. Those are all the producing counties in Texas in the last 18 months. And you see state and county, these are unique columns. There's not duplicates in here. What is being done is all of the columns in that we're calculating the average oil daily and gas daily for every single one of these counties. So next thing I want to do is use those FIPS codes, right? FIPS codes are a standard way of mapping out counties in the US. And I'm going to join my county name and my state name on this FIPS table called get FIPS, which pulls back a data frame that you can use as a lookup, so that I'm preparing my data frame for it to be processed into a map. So the first thing I do is I pull get FIPS, and that creates a data frame, and then I merge it in. You can see here I'm turning the county information from my data frame into an uppercase string. By default, get FIPS uses uppercase strings. That way it controls for any differences in capitalization. Then I'm using a merge function, and I'm using a right join. A right join means I'm preserving the information inside the FIPS code, so that way I get all the counties in Texas, right? So even if there's a county that wasn't producing anything, I'm pulling it in here just so that I can see it on my map. And then the last thing I'm doing is for all counties that don't have any values, those that weren't present in producing, I'm just setting them equal to 0 using a fill NA function. So let's run that and see what it looks like. Okay, so now I've got 254, which accounts for every one of the counties in Texas. And I've got a clean gas daily, oil daily, and FIPS column. So with that information, the last thing I have to do is create a county map. And for that, I'm going to be using Plotly again. So the arguments I'm passing in, first of all, is I want my FIPS code to be set equal to my FIPS column up here. You can see the column name is FIPS, and I'm setting FIPS equal to that column. Next, for values, I'm going to do gas daily, right? So I'm going to look at the gas daily values first. For the county outline, that just kind of helps make the chart look a little bit prettier. I'm basically setting the borders to white. For the scope, I'm saying we only want to look at Texas. We don't need to plot any of the nearby states. And then binning endpoints, I'm setting the cutoffs for the colors that represent the different values in the state. So because Texas is so diverse, there's so many different kind of plays that produce very different oil and gas profiles, I want to use something that's going to scale. So I've written a little inline code here that basically takes a base value and then it doubles it. And it doubles it 10 times, right? The range between 1 and 11. It doubles it 10 times so that you can exponentially see where the biggest producing ranges are, but you can also really clearly see the differences between them. So I am going to hit play. And just like that, I've got my map of Texas. You can see the Eagle Ford very clearly. You can see the Permian. Now remember, I'm mapping this for gas, not oil. I'll do oil in a second. But like I was saying, the western part of the Permian tends to be a lot gassier, and you can see that very clearly in this chart. And then you can see the Haynesville. The Haynesville obviously stands out well apart from the other place in Texas when it comes to gas production. But look what happens when I switch it over to oil. So to do that, all I have to do is change my value column. I'm going to do oil daily instead of gas daily. And I'm going to change my base a little bit. You can play with these to see what looks good. Now I run that, and it's like the Haynesville doesn't even exist, right? The Haynesville is an extremely dry play, whereas the Permian, the eastern side of the Permian has started to light up a little bit more, and the Eagle Ford is much, much more defined because those are the oily plays of Texas. All right, that's how you very quickly use the Hyperion IP or Python add-in to do IP rate analysis. If you have any questions, you want any help with doing your own analysis, please contact me. My email is eric, E-R-I-C, @synmax.com. Thank you.